50 years ago, NASA conducted an experiment on the surface of Mars. The results came back positive. And then the agency spent the next 5 decades quietly making sure you never heard about it. This is the story of the Viking mission, the first spacecraft to successfully land on Mars.
Viking was the first spacecraft to reach the surface of Mars and be an operational spacecraft. And the key challenge, and the reason everyone failed before Viking, is called entry, descent, and landing.
And why the most important finding in the history of space exploration was buried under a mountain of scientific caution, institutional politics, and fear of what the answer actually meant.
A moment in every Viking's life that he or she will never forget, sitting with that television right in front of them and watching as the first lines came down. It came down line by line by line.
To understand what happened, you need to understand where NASA was in 1972. The Apollo moon landings were over. The space race was won. And the American public, which had been gripped by the drama of men walking on the moon, had started to look away. Congress responded the way governments always do when public attention fades: they cut the budget. The original plan had been something called the Apollo Applications Program. The idea was to take everything NASA had just learned from the moon and point it at the next target, Mars. Human boots on Martian soil by the early 1980s. That dream died in a budget meeting. But Mars didn't go away. Scientists had been staring at grainy images from the Mariner probe since 1965, and what they saw was tantalizing.
There's no way to describe it. We were lifted up. Everybody kept walking around. This photograph will be in the books 1,000 years from now.
Ancient river channels, dried lake beds, canyons carved by flowing water. Mars hadn't always been the frozen desert it is today.
Touchdown confirmed. Receive on
There was a time when it looked a lot more like Earth. And anywhere there is liquid water, there is at least the possibility of life. So instead of sending humans, NASA designed something smaller. 2 identical spacecraft, each consisting of an orbiter and a surface lander. 2 chances to get it right. 2 regions of Mars to explore simultaneously. The mission was called Viking. Viking 1 launched on August 20, 1975, from Cape Canaveral on board a Titan Centaur rocket. Viking 2 followed 19 days later. After 11 months of drifting through deep space, Viking 1 arrived at Mars on June 19, 1976, and slipped into orbit. The landing on July 20 was fully automated. At that distance, a radio signal takes 19 minutes to reach Earth, which means by the time Mission Control knew the landing had started, it was already over. Everything had to be handled by an onboard computer the size of a suitcase running on 1970s technology. The lander entered the Martian atmosphere at roughly 8 times the speed of sound. A heat shield absorbed the friction.
They let the parachute do its job and descend toward the ground. Even they were going very, very fast. Once they got to about a mile or so above the ground, their lander, which had a local short-range radar, decided, hey, it's time to separate. So it fell away from the back shell and the parachute that was suspending it above, and it fell away, and then they lit their rockets. Just a short
Parachutes deployed at 6 kilometers altitude and bled off as much speed as they could, but Mars has a thin atmosphere, only about 1% of Earth's, and parachutes alone can't save you there. At 1.5 kilometers, the chutes released and 6 landing thrusters ignited.
Land on the surface, scoop up some soil, and see whether or not this planet had developed life. Well, we're still looking for that life, but today we think it's in particular areas. It's not just anywhere on the planet, so we have to be special about where we go to look for it.
40 seconds later, Viking 1 made contact with the surface of Planitia. Within 25 seconds of touchdown, the first image arrived.
Every single time we have gone there, it's been a brand new Mars, but the biggest brand new Mars of all time was in July of 1976.
Rocky volcanic terrain stretching to the horizon under a butterscotch sky. Mars, up close, for the first time in human history. But the images weren't the point. The reason Viking cost the equivalent of several $1 billion in today's money was the biology lab sitting inside that lander. 3 separate experiments, each one designed to detect signs of microscopic life in the Martian soil. The first was the gas exchange experiment. A robotic arm scooped up a small sample of Martian dirt and deposited it into the onboard laboratory. The sample was then exposed to water and nutrients. Researchers monitored for gases that living organisms would release as byproducts of consuming the food. The result, a strong release of oxygen and carbon dioxide. Positive. The second was the pyrolytic release experiment, which looked for evidence of photosynthesis by exposing the sample to carbon dioxide and ultraviolet light. The result was a weak but detectable positive signal. The third experiment, and this is the critical one, was called the labeled release experiment. It was designed by a NASA scientist named Dr. Gilbert Levin. The concept was elegant: expose the soil to nutrients that had been laced with a radioactive tracer. If living organisms consumed those nutrients and released carbon dioxide, that gas would carry the radioactive signature. Chemistry alone could not explain that result. Only biology could. The labeled release experiment on Viking 1 returned a strong positive. When Viking 2 touched down on Utopia Planitia 2 months later and ran the exact same series of tests, it returned the exact same results. By every measure of those 3 experiments, Mars had life. So why didn't the world find out? Because there was a 4th instrument on board Viking called the gas chromatograph mass spectrometer. Its job was to detect organic molecules, the carbon-based building blocks from which all known life is constructed. And it found nothing. No organics. Not a single carbon compound in the Martian soil. For NASA, that was the end of the conversation. The agency had made a deliberate decision before the mission launched. The results had to be unambiguous.
By the time we could see 5 or 6 lines, we could actually start seeing the outline of a rock.
And you saw 1 section, and 2 sections, and 3 sections, and you started seeing the surface of Mars, and then you knew we had done it.
Either life was confirmed across every single experiment, or the result would be classified as inconclusive. There was no middle ground. The potential consequences of announcing extraterrestrial life, the philosophical, religious, and political fallout, were simply too enormous to risk on anything less than total certainty. So inconclusive it was. Dr. Levin spent the rest of his life arguing that NASA had found life and then walked away from the answer. Most of the scientific community disagreed. The textbooks sided with NASA. And that is where the story was supposed to end. Except here is the problem. In 2014, NASA's Curiosity rover found organic compounds preserved inside Martian rock, a chlorinated hydrocarbon called chlorobenzene. In 2018, it found more organics in a sample of ancient mudstone. And in 2025, Curiosity identified long-chain hydrocarbons structurally similar to fatty acids, the same class of molecules believed to have played a foundational role in the emergence of life on Earth. The one thing that caused NASA to dismiss the Viking results in 1976, the absence of organics, has now been proven wrong. The building blocks were there all along. The instruments on Viking simply weren't sensitive enough to find them. Which means that if Viking had been flying today's equipment, the conclusion would have been different. And the world would have known about it 50 years ago. 5 more landers have visited Mars since Viking. Not one of them has repeated the labeled release experiment. There is a version of history where July 20, 1976 is the day humanity discovered that we are not alone in the universe. Instead, it became just another date. But the question Viking was asking is still out there, unanswered, waiting on the surface of a cold red planet 225 million kilometers away. We need to go back. And this time, we need to be ready for the answer.